Okay, so a couple more calculations on capacity. So remembering that capacity is just a measure of the amount of liquid or gas that something can hold. If your measurements are in, if your original measurements are in centimetres, then your answer is also in millilitres. If you originally measure your measurements in metres, then your answer, your volume would be in metres to the power of 3, and each metre to the power of 3 would be equal to 1,000 litres. So I'm going to do two of the questions here. They're from the CLUP textbook. So I'm going to do the one that looks like some of our troughs around the farm, and I'm going to do the one that looks like a swimming pool because they love these sorts of questions in the exams. So let's have a go. So firstly, for the one that looks like half a cylinder, basically you're going to get your volume first. So your volume, you're going to use the formula for the entirety of a cylinder, which is pi times your radius squared times your length. And then we've only got half of the cylinder here, so we're going to halve it. So here we're going to have pi times, they've given us the length across the full back, which is 1.4. So half of that for my radius would be 0.7 squared times the length of my object, which is 2. Now these were all in metres, so I didn't need to do any other conversions, but the other favourite exam trick is that they'll give some of your measurements in metres and some of them in centimetres. So make sure all your units are the same before you proceed. In this case mine are, so I can carry on. And I'm going to do that, and then halve my answer because I've only got half of that sphere, half of that cylinder, and so I would wind up with a final answer here of 1.539 metres to the power of 3. Now, because I've measured my my object in metres, my answer is basically in kilolitres. So it would make sense here just to go with litres. So to convert this to litres, I'm then going to, so my capacity, I'm going to times it by 1,000. So my capacity would equal to my 1.539 times the 1,000, 3 zeros, so I'm moving my decimal 3 spots, would give me 1,539 litres. Now, also, the only other trap that you need to watch here is your decimals. Some people tend to round prematurely, and if you got to this point and you'd rounded this to 1.5, then when you times it by 1,000, you're going to get 1,500 litres, and your answer is going to be very slightly out. So we always, in all of your questions, I always try and reiterate that point that there's no rounding right until your final answer. So leave all your decimal places in right until the end. Now, I can't remember whether I actually had more decimals than my 539, but because I know in the back of my mind I'm going to be timesing this by 1,000, I know I needed to leave at least 3 decimals if I was going to truncate that number any earlier. Okay, let's go on to this question 22 here. What people miss in these ones is the nature of the shape. And in most exams, there's been a shape sort of something like this, and people kind of start going, okay, well, I'm going to turn this into a rectangle and a triangle or something along those lines. But of course, what you've really got here is you've got a trapezium. And so my two parallel sides for my trapezium are the two ends of the pool. I've then got this measurement here, which is going to be my height, and I know that because my height has to come off my 90 degrees. Now, what CLUP's done here is a favourite exam trick of, instead of giving you that height, he's given you the slope, and it's a bit of a distractor because that's not actually useful in measuring it. And what they're looking for you to do in this exam is to use Pythagoras to find the height. So, well, when we say heights, we call it a height in the thing. Of course, it would make more sense in this context to call it a length. But our formula for a trapezium, when you look in your notes, is A plus B, where they're my two parallel sides, divided by 2, and then timesing it by height is what you'll have in your formula sheet. That would give you just the area of this face of the trapezium, and then we'd be timesing it out by the length of this shape to make it into a three-dimensional object to get that volume. So that's essentially what I'm plugging into. But first, what I'm missing is that height. So to get the height, basically, and I'll just change colours here again and show you. So basically, I'm going to use this triangle here, okay, and use Pythagoras. So it's one of the short sides that I'm finding, so I'm going to be getting the square root of the long side squared, so the 25 squared, take away the short side squared, which means I need this measurement here. Now, to get that one, they've given me the 2.5 at this end, and they've told me that the other end is 0.5. So 2.5, take the 0.5, means that height there was 2 metres. So 25 squared, take the 2 squared, is going to give me the height here. The length, what we've called a height in our formula. So 24.92 metres. And again, you know, if you've got decimal places, leave them in there right until the very end of the question. So my final solution here is going to be my A plus B, so my 0.5 plus my 2. Don't forget, if you're not using a two-dimensional button in your calculator, to put a bracket around this, because otherwise you're going to get a tragic BIMDAS error. I'm going to divide that by 2 and times that by the 24.92, which was the height of my overall trapezium, and I'll change colours again. So what we found there in that part of the formula is the face of this trapezium, and then timesing that out by the length of the shape, which is my 10 metres, would give me a final volume calculation of 373.798 metres to the power of 3. Now, this looks like a swimming pool, so and in fact they've said here to the nearest 100 litres. So to turn my volume measurement, my metres into litres, I'm going to need to times this answer by 1,000. So my capacity is equal to the 373.798 times by 1,000. And again, mentally, you know, I've got 3 zeros, so I'm moving that decimal 3 places. So that's going to give me an answer of 373,798 litres. This question, and make sure you do read your questions carefully, have asked you to give your final answer to the nearest 100 litres. So I would show that I've done that by saying it's approximately 373,800 litres to the nearest 100. Remembering that if I'm stopping at the nearest 100, that's going to be my last, what we call significant number, and I'm filling in the rest with zeros. Okay, that should do you. Thank you.